During a recent broadcast on Russian state-run television, a deeply concerning scenario was raised by a military analyst: the potential use of Russia's RS-28 Sarmat intercontinental ballistic missile against seismic fault lines in the United States, specifically the San Andreas Fault. This chilling discussion took place during a segment on the Russia One program hosted by Vladimir Solovyov, where military pundits and commentators openly examined the destructive capability of nuclear weapons, not only as tools of warfare, but also as geological triggers. Retired naval officer Konstantin Sivkov, a frequent guest on Kremlin-affiliated platforms, described the Sarmat as a so-called special weapon. With its ability to carry numerous nuclear warheads and strike from directions rarely considered in traditional defense scenarios, including routes over the South Pole, the weapon has been described by Russian officials as nearly unstoppable. During the televised discussion, Sivkov argued that the United States was particularly vulnerable to strategic strikes on geologically sensitive areas, and he referenced the San Andreas Fault as a potential target that could cause catastrophic consequences for the entire western region of North America. The San Andreas Fault is a massive tectonic boundary that stretches roughly 1,200 kilometers through California. It marks the meeting point between the Pacific Plate and the North American Plate. The region is under constant pressure from the slow, grinding motion of these two plates. While small earthquakes are common, scientists and seismologists have long warned of the possibility of a major rupture, a so-called big one, that could bring widespread devastation to densely populated cities like Los Angeles and San Francisco. This fault line has not experienced a full-scale release of tension in certain segments for over 100 years, making it particularly dangerous. In his broadcast comments, Sivkov stated that a direct strike from a weapon as powerful as the Sarmat, or even from a deep-sea nuclear detonation near the fault zones via Russia's Belgorod submarine, could potentially activate dormant segments of the San Andreas Fault. He pointed to the proximity of other geological hazards, such as the San Jacinto Fault and the Ring of Fire's volatile volcanic arc, indicating that a chain reaction could occur. The implication is that instead of targeting cities directly, a strike could exploit natural vulnerabilities to generate destruction on a far greater scale than conventional attacks. The theoretical consequences of such an event are dire. If the San Andreas Fault were to be triggered by a massive shockwave, especially one delivered from a powerful missile or deep-sea explosion, it could result in a multi-state disaster. A high-magnitude earthquake along this fault could destroy infrastructure, collapse highways, disrupt communication systems, and cause large-scale fires. Hospitals, emergency services, and supply chains would be overwhelmed in minutes. Millions could be displaced. The economic repercussions would be beyond calculation, with global markets also likely to be affected. The idea of weaponizing nature, especially targeting geologically active regions, is not entirely new, but discussions of it by high-ranking analysts on national television give it renewed urgency. The San Andreas Fault is already considered one of the most closely monitored seismic zones in the world, but its unpredictable nature makes it impossible to defend against artificially induced earthquakes. Unlike traditional military targets, faults cannot be hardened or protected. They are deep within the Earth and are triggered by forces far beyond human control, but potentially within human influence. Beyond the physical destruction, the psychological impact of using such a tactic would be equally devastating. The idea that a natural disaster could be deliberately set off by geopolitical enemies changes the nature of warfare. It transforms the environment into a weapon and places entire populations under a type of threat for which there is no true defense. Civilians would live with the knowledge that their lives could be upended not just by conventional conflict, but by tectonic forces manipulated through technological means. Adding to the tension is the presence of Russia's Belgorod submarine in the Pacific Ocean, as noted by Sivkov. The Belgorod is believed to be equipped with Poseidon underwater drones, which could theoretically be used to create underwater shockwaves. While no evidence has been presented to suggest that such weapons have ever been tested in this way, the concept is deeply unsettling. With California's most dangerous fault lines situated so close to the coast, an underwater detonation, even far from land, could theoretically impact these zones if it were large enough and correctly positioned. The discussion of such tactics also raises profound ethical and environmental questions. Deliberately triggering natural disasters would set a dangerous precedent, and could result in consequences far beyond what any strategist could predict or control. Earthquakes do not respect borders, and geological chain reactions could spiral unpredictably, affecting neighboring states and even international regions along the Pacific Rim. In the face of such rhetoric, global leaders, scientists, and the public must take these discussions seriously. Even if such strategies remain hypothetical, the mere suggestion of using Earth's natural systems as tools of war highlights the urgent need for renewed diplomatic efforts, stronger global non-proliferation agreements, and investment in geological resilience and preparedness. The San Andreas Fault, while a natural marvel and scientific interest, should never be used as a pressure point in the game of international conflict. If the big one were to strike along California's San Andreas Fault, the financial cost would be staggering, measured not in millions, but in hundreds of billions of dollars. While the fault produces frequent small earthquakes, scientists have warned for decades that a major rupture is inevitable. When it does occur, the destruction could reshape entire regions of the state and create economic ripples that extend across the United States and beyond. Modern estimates from earthquake simulations suggest that if the big one were to hit the southern segment of the San Andreas Fault, particularly near the heavily populated Los Angeles region, the immediate damage to buildings, infrastructure, and utilities alone could exceed $200 billion. This figure accounts for collapsed or severely damaged residential properties, high-rise office buildings, schools, hospitals, and other essential facilities. Bridges and overpasses could fail, railways could be twisted beyond repair, and runways at airports could crack, limiting emergency response and evacuation efforts. Beyond the direct structural losses, the disruption to essential services would compound the damage. Electricity grids could be down for days or weeks, gas lines could rupture and cause widespread fires, and water systems could be damaged so severely that millions of residents would be without a safe supply. Repairing and replacing this infrastructure would add tens of billions of dollars to the recovery bill. The economic fallout would also be amplified by business interruption costs. California's economy is the largest of any US state and ranks among the largest in the world. If factories, shipping ports, technology hubs, and entertainment production facilities were forced to close for weeks or months, the lost productivity could amount to hundreds of billions more. Tourism, one of California's major industries, would grind to a halt as travelers cancelled plans and international visitors avoided the disaster zone. Insurance claims would flood in, straining the financial sector and potentially forcing federal disaster relief funding into record-breaking territory. The ripple effects would not stop at California's borders. The state is a major agricultural producer, supplying fruits, vegetables, and dairy products nationwide. A disruption in food production and distribution could cause price spikes across the country. The ports of Los Angeles and Long Beach, which handle a significant percentage of the nation's imports, could be damaged and closed for extended periods, choking supply chains and delaying shipments of goods from electronics to clothing to automotive parts. In total, when direct physical damage, infrastructure loss, business interruption, agricultural impact, and supply chain disruptions are combined, the total financial toll of a major San Andreas rupture could realistically surpass $500 billion. This figure does not even include the immeasurable costs of human displacement, long-term housing shortages, and the mental and emotional strain on millions of residents. While California has invested heavily in earthquake preparedness, through stricter building codes, seismic retrofitting programs, and public education, no amount of planning can fully prevent the massive financial shock that would accompany a disaster of this scale. The big one remains an unavoidable geological certainty, and when it happens, the economic losses will serve as a stark reminder of both the power of nature and the vulnerability of even the world's most developed regions. The truth is that the San Andreas Fault is not just a geological boundary. It is a fault line running through the heart of the American economy, and the day it ruptures, the price tag could be among the largest for any natural disaster in history. Something odd has been discovered by the Chinese exploration rover on the Moon's far side. An oddly colored, gel-like substance has been found in a small crater on the far side of Earth's only permanent natural satellite by the Lunar rover, U2. On the 8th lunar day of the rover's mission, which started on July 25th, the discovery was made. The scientists on the project, decided to change the rover's route in response to this intriguing discovery. The mission team decided to focus on the space goo instead of continuing the lunar probe's intended westward path. The odd material was subsequently examined by scientists using rover's visible and near-infrared spectrometer in an effort to identify it. Using this instrument, the scientists can determine a material's composition by examining the light that is reflected or scattered off of it. At the time of the discovery, the lunar mission crew from China kept quiet about the discovery, saying only that the material is gel-like and has an unusual color. Scientists detect hazardous radiation levels on the Moon. The levels of space radiation on the Moon appear to be 2 to 3 times higher than those experienced on the International Space Station. This presents unprecedented danger for astronauts exploring the Moon in the future. In January of 2019, the robotic spacecraft mission in the Chinese lunar exploration program made scientific history as the first soft landing on the far side of the Moon. The Moon probe provided radiation data to the Chinese-German team for the full radiation exposure from the lunar surface, and it was significantly higher than anticipated. Despite the height of the radiation levels, this is a huge achievement and advances our knowledge by exponential amounts and can serve as a benchmark for radiation levels we measure elsewhere. Thomas Berger, a physicist with the German space agency Medicine Institute, says that we now have a better understanding of the risk of radiation to those on the Moon. The 1960s and 1970s Apollo missions, most notably Apollo 11, proved that it is safe for humans to spend a short number of days on the Moon. However, NASA did not record the daily radiation measurements, meaning we could not determine the duration that would be safe for crews to stay. This new data changes that, and we now know that the radiation levels on our Moon are 200 times higher than those on Earth. The explanation for such a high difference between the levels of radiation on the Moon, to the International Space Station, to the Earth, is effectively due to the Earth's magnetosphere. Earth is entirely within, the International Space Station is half submerged, and the Moon is not within the magnetosphere. The magnetosphere deflects a large proportion of the radiation from space, consequently lessening the radiation we experience on Earth. This radiation is produced from a variety of sources, some including the galactic cosmic rays, sporadic solar particle events, for example, solar flares, as well as neutron and gamma rays. NASA's Artemis mission aims to have individuals on the Moon for a long-term period of time, both living and working on the Moon's surface. After multiple delays, Orion's first Space Launch System launch, originally scheduled for 2016, took place on November 16, 2022. The planned schedule for the crewed Artemis II launch is for late 2025. The crewed Artemis III lunar landing is for late 2026. The Artemis IV docking with the Lunar Gateway is for late 2028. The Artemis V docking with NASA's Lunar Terrain Vehicle and the Artemis VI docking is for early 2031, when the crew and science airlock will be integrated with the Lunar Gateway station. It is estimated that without additional measures in place, a human could stay on the Moon for 2 months, though an extended period would require protective measures to be implemented. An example of this measure could be an 80-centimeter wall of lunar soil built around habitats in order to shield humans from radiation. Astronomers discover water exoplanet. One part of space exploration that is particularly fascinating is the discovery of and search for planetary bodies. When we are lucky to stumble across those outside of our solar system, we call these exoplanets, and this has been the focus of plenty of recent research. Research published in the Astronomical Journal in mid-August 2022 details a discovery in which researchers believe that they might have uncovered a new exoplanet that has been dubbed a water world, thanks to the possibility that the surface is entirely covered in water. It was an international effort that went into the discovery, with the team being led by Charles Cadieux, a student and member of the Institute for Research on Exoplanets, also known as the Institute for Research on Exoplanets, and the primary equipment used to detect the initial signals being the Transiting Exoplanet Survey satellite, operated and made by NASA. This water-world exoplanet was found approximately 100 light-years away from Earth. It appears to be orbiting one star out of 2 that form a binary system which can be traced to the Draco constellation. A binary system is when 2 stars orbit one another, forming one system together. This waterworld planet orbits one of those in this system, not too dissimilar from how Earth orbits the Sun. The distance from the stars mean that the surface temperature of the planet could facilitate water, making the possibility of an ocean planet fairly likely. They believe that the surface of the planet could simply be a thick layer of water, comparable to some of Jupiter's and Saturn's moons, such as Enceladus, or perhaps more notably, Europa. The Transiting Exoplanet Survey satellite, NASA's equipment designed to look for exoplanets, works by detecting fluctuations in the brightness of a star that might indicate an exoplanet is passing in front of it. It surveys the whole sky, with the primary aim being to detect planetary bodies similar to our own, though it does not hurt to find interesting ones like this too. The detection indicated that this planet may be about 70% larger than the Earth is. This was calculated due to the decrease in brightness being picked up every 11 days. While the Transiting Exoplanet Survey satellite might have first picked up these signals, it was not just this one piece of equipment that took on the work. It is this further research that is required to confirm the type of planet it is, as well as other possible characteristics. The discovery of exoplanets, planets that orbit stars outside our solar system, has revolutionized our understanding of the universe and the potential for life beyond Earth. With thousands of exoplanets identified since the first confirmed discovery in 1992, scientists are increasingly optimistic about finding planets that could support life. To assess the habitability of exoplanets, scientists consider several critical factors that support life as we know it. The concept of the habitable zone, also known as the Goldilocks zone, is central to the search for life. This is the region around a star where conditions are just right for liquid water to exist on a planet's surface. Water is essential for all known forms of life, serving as a solvent in which biochemical reactions occur. If a planet is too close to its star, it will be too hot, causing water to evaporate. Conversely, if it is too far away, water will freeze. A planet's atmosphere plays a crucial role in maintaining surface conditions conducive to life. An atmosphere can provide essential gases, such as oxygen and carbon dioxide, which are necessary for processes like respiration and photosynthesis. Additionally, atmospheres can regulate temperature through greenhouse gases, preventing extreme temperature fluctuations that could be harmful to life. Geological activity, such as volcanism, can contribute to a planet's habitability by recycling nutrients and maintaining an active climate. A magnetic field, generated by a planet's molten core, can protect the atmosphere from being stripped away by stellar winds, preserving the conditions necessary for life. Among the diverse types of exoplanets discovered, certain categories show promise for supporting life. Earth-like planets, or terrestrial planets, are rocky worlds with similar size and composition to Earth. These planets are prime candidates for habitability because they have solid surfaces where water can pool and atmospheric conditions that can support life. Super-Earths are exoplanets with masses larger than Earth's but smaller than that of Neptune. Their increased gravity can help retain a thicker atmosphere, which can support a stable climate and protect against harmful radiation. Understanding the breadth and depth of advanced civilizations beyond our planet requires the imagination to peer through the lens of possibilities not limited by our current scientific and technological grasp. In his book, Ringmakers of Saturn, Dr. Norman Berggren, a former NASA research scientist, presents remarkable photographs captured by Voyager 1 during its 1980 flight. The purpose of sending Voyager 1 to Saturn's rings was to explore peculiar anomalies previously observed from Earth, and the images sent back by the mission left NASA astonished. Berggren, who was employed at NASA's Ames Research Center in Moffett Field, California, achieved recognition with esteemed accolades, such as the Archimedes Engineering Achievement Award, presented by the California Society of Professional Engineers. In addition to his affiliation with NASA, Berggren also contributed to classified and notable aerospace endeavors at Lockheed Martin. Having access to classified documents during his tenure had its consequences, as Berggren himself mentioned in an interview with Project Camelot. He emphasized that he had to make a long-term commitment by signing confidentiality agreements for 30 years. Despite the passage of time, Berggren hinted that there are still limitations on what he can disclose, and he expressed concern that his safety would be at risk if he were to divulge too much information. Having been granted exclusive permission to view the original NASA photographs transmitted by Voyager 1 in 1980, Berggren personally observed something that was kept hidden from the public eye. As a result, he became the first credible and confirmed member of the scientific community to uncover the existence of cylindrical vehicles. Berggren's findings were revealed in his book, which provided a detailed account of what Voyager 1 had witnessed. However, despite facing difficulties in getting his book published in the United States, Berggren eventually found success in Aberdeen, Scotland. In the book, there is a picture of an object in the A-ring of Saturn that was intentionally created and referred to as an electromagnetic vehicle. This object was remarkably massive, measuring 2,000 miles in length and over 450 miles in diameter. The construction of an object of such magnitude would require advanced technology, and it raises questions about the identity of the individuals or entities capable of achieving such an extraordinary engineering task. Dr. Berggren revealed that he was uncertain about the origins of a peculiar entity. However, his findings indicated that these entities are present in Saturn, where he first observed them. Interestingly, they have now been detected in Uranus and Jupiter as well, particularly in areas with rings. Dr. Berggren refers to this phenomenon as the ringmaker. In his analysis of the unusual images from Voyager 1, he provided a description, stating that he observed parallel lines intersecting all of the rings simultaneously. He concluded that these lines delineated the outer boundaries of an object, providing limited visibility. In his explanation, he clarified the nature of the object he was observing as an electromagnetic vehicle. His reasoning was based on his ability to perceive streamline patterns, which he recognized as potential lines, commonly associated with electrical phenomena. Berggren speculated that these spacecraft might be responsible for the creation of the rings, which is why he titled his book accordingly. However, other experts suggest that they could be engaged in extracting the valuable metals and nutrients that compose the rings. Regardless, this is an astounding find that seems to have been kept hidden from the public. A reviewer of Berggren's book described Saturn's rings as unnatural and believed them to be byproducts of colossal cylindrical objects with dimensions comparable to Earth's. In the realm of speculative astrobiology and futurology, a civilization's technological advancement is often gauged by the Kardashev scale. Proposed by Russian astrophysicist Nikolai Kardashev in 1964, this scale initially included 3 levels of civilization, based on the amount of usable energy at their disposal. A Type 1 civilization uses all available resources on its home planet, a Type 2 harnesses the energy of its local star, and a Type 3 can utilize energy on the scale of its own galaxy. A Type 3 civilization would have developed technologies and techniques far beyond our understanding, potentially achieving significant feats, such as building Dyson swarms or spheres around numerous stars to harness their energy, creating galaxy-spanning structures, or tapping into the power of supermassive black holes found at the centers of most galaxies. To grasp the technological prowess of a Type 3 civilization, we must first comprehend the sheer scale of their energy consumption. Our Sun alone releases more energy in 1 second than humanity has consumed throughout its entire history. Now, imagine harnessing the energy of billions of such stars. The result would be a civilization capable of shaping its galaxy according to its needs and desires. Given this scale, such a civilization would likely have achieved interstellar travel, be capable of manipulating space-time to their will, and have highly advanced technologies for information processing and communication that span across light years. They could be masters of advanced sciences, such as quantum mechanics, artificial intelligence, and genetics, leading to unimaginable breakthroughs in knowledge and capabilities. Furthermore, the societal structure and culture of a Type 3 civilization is another source of profound speculation. They could potentially have transcended biological forms, evolved into digital consciousness, or developed forms of communication and societal structures beyond our comprehension. However, as with all conjectures about advanced life, the existence of a Type 3 civilization raises questions and paradoxes. If Type 3 civilizations exist, their influence and activity should be noticeable, yet we observe no such evidence. It's important to recognize the speculative nature of these discussions. As of today, humanity is not even a Type 1 civilization on the Kardashev scale, and the leap to Type 3 is almost unimaginable. Yet these discussions serve a valuable purpose, not just as intellectual exercises, but as tools that allow us to explore our future and set aspirations for technological advancement, space exploration, and our understanding of the cosmos. Although Kardashev did not officially extend the scale beyond Type 3, futurists and speculative scientists have suggested higher levels, including the concept of a Type 4 civilization. A civilization of this magnitude would command power equivalent to the energy output of the entire universe. This thought-provoking concept challenges our understanding of technology, energy use, and the very fabric of existence. A Type 4 civilization would wield unimaginable technological prowess, transcending our current laws of physics.